Good afternoon, and welcome to the best talk in Devnexus. My name is Wesley Hales, and I'll briefly tell you, I work for a company in Mountain View, California called Shape Security, and we basically rewrite JavaScript and HTML and CSS on the fly for every request. So if you want to talk about that later, feel free to come up and ask me about it. I used to live here in Atlanta, and I just moved out to Silicon Valley about a year ago, and it's cool, you know, the valley. It's pretty expensive to live out there, but it's overall, it's like a kid in a candy store for a technology person, because you could literally go to a meetup or some type of meetup every night and live on pizza and beer. So it's, I don't do that, obviously. I have a little bit of problem with beer. So anyway, on to measuring page load time. So this talk is we're gonna break it down. We're gonna talk about how to measure page load time from a very basic level. I'm gonna show you a ton of examples. I'm gonna go back and forth between the slide deck and the web browser, so be prepared for that. We're gonna talk about how we used to measure page load time, how we measure it today, and how we can automate that and put it into a Docker container with PhantomJS. And I'm going to go through the whole run of the mill with you, so no worries. We got plenty of time. So where do we start? When we're measuring performance, we have to get the time, right? You have today in JavaScript, you have date.now or date.getTime. Date.now does not work in IE 9 or below, I believe. But anyway, you know, we find out when the page was loaded, when our script's executed, we run a function, or we perform something with JavaScript, and then we figure out how long that took, right? So let's do that really quickly. Let's see, what is it? Simple. So this guy, if we view source on this, it's two things. Let me increase the font for you here. I will do that for all of these windows, by the way. So this source code basically does two things. It prints out a console line in the head and within the body, where we typically are told to put our JavaScript in the body tag at the bottom. For various reasons, but here, as an example, I just wanted to show you what both date.now and date.getTime do. It's very simple. They both return the same epoch, or epoch, depending on how you want to say it, timestamp. This one is date.now, this one is date.getTime. So they're sitting side by side. So that should tell us, you know, when our JavaScript started executing. Oh yeah, don't need the quotes. So at 14:37 on March 11th, that console line executed. And it's not a truly accurate measurement. There's a lot of problems around this function. And if you're, you know, I use date.now for certain things, but you have to know when to use it and when to use the new APIs that are available to us. So when did this JavaScript execute and how it executed? That's what we're going to talk about. So let's jump back over to the deck. So JavaScript time is very inaccurate. It's skewed by the system clock. So depending on what your clock is set to, that's the date that you just saw in the console. It's what's on my system. And it also can't provide any data regarding the server, the network, what the response time, how long the DNS lookup was. And so that's what we're going to get to eventually. So let me show you another example. So here we have a little more of a complex scenario. So let's do this. And in the console, all I'm doing, actually I'll show you the source code first, because that's an image. I can't get to the source. First thing is first. So here at the very earliest that I can do it, I'm getting the time, right? So I'm going to set that in a global variable on window. Now it's 0. It's just some basic setups and labels. We have a function to get the current time as well. So the difference between this top function, or this top statement, is that it will be executed when the page is parsed and the JavaScript engine executes it. This function is just a wrapper around getting the time. So I have my time first, the very top, when the script was executed. That's my baseline. And the function is going to give me the current time so I can make measurements, right? So I'm going to take the baseline and subtract that by whatever the current time is and figure out where I'm at in my code, how long it's taken to process something. So what we're going to do next is we're going to print out when this actually started. So again, like I just said, I'm going to call this getTime function here, and I'm going to subtract it by the global variable I set when this page was first rendered. So as you can see here, our script execution starts at 1 millisecond. It takes 1 millisecond for that script execution to start, but is that truly the case? How do we know that because our system clock is skewed, or there was some other variable, or I had some other process going on in the background that caused my JavaScript engine in the browser to do so? Basically what I'm saying is there are a lot of variables in play. So how can we get a more accurate and better picture? So let's try something real quick. What was that? So what I'm gonna do, kill that. I'm gonna add something else here. I'm gonna say, oh, really? Actually, I'll leave that out. And then we'll do performance.now. You don't know what performance is unless you're familiar with navigation timing APIs. I'm going to go over exactly what it does in just a minute. So let's save that. Let's reload the page. And I obviously left something out. Oh. Now I understand. There we go. And this time, sorry for the slow talking here. So we added this oh really statement in here, and now we've got this number 6 milliseconds. So as you can see, previously thought by using date.now and subtracting that from the current time, I thought that it took my script 1 millisecond to execute, but in reality it took 6 seconds. So let's talk about that. Actually, you know what? We're going to talk about HRT in a few slides from now. I want to go over the rest of what we're doing today first, and then we'll jump into why that script execution took 6 seconds instead of 1 millisecond. So let's continue to go through how we measure things today. So who in here is familiar with DOM content loaded? Who has added this listener to their page at some point? Maybe someone. Yes, there's quite a few people. Okay, so this is the old way of telling when the document has been completely loaded. In the spec, it says that style sheets, images, and subframes have not finished loading. So it's basically the document loads, and we get that event listener is fired. So let's look at that real quick. So again, I have that. So we just saw this code here, the get time, how long it took my execution to start. Now we're going to add this event listener of DOM content loaded. And we're going to get the original time I set and subtract it, and we're going to have a rough measurement of when that was actually loaded. So DOM content loaded is down here. So basically what's in this HTML page and what's being printed out here in the console is every possible listener we've had over the past X amount of years in all the browsers to measure page load time. So I'm just breaking this down for you, showing you what's been available in the past, and then we'll move on to what's available now. So we had other things going on. So our script execution started at 0 milliseconds this time. I could get a more accurate read from that. We start blocking, so I've got a for loop in there that calls document.write. I'm purposely blocking the UI thread to get to see how these events fire. So we blocked the UI. It was blocked for 10 milliseconds. The script execution has stopped, but the DOM is still loading, so we get this ready state interactive thing, and then we get down to DOM content loaded. So just so you know, in the lifecycle of a web page, that's where DOM content loaded occurs. All right? So next, we'll look at the load event. Body on load. It's leveraged by many JavaScript frameworks and developers and jQuery, and there's a lot of controversy around it. You know, we've bared the brunt of on load for many, many years. So there's two ways to get the load event fire, and there's actually more ways, I think. But it's fired when a resource and its dependent resources have finished loading. So this was kind of the most accurate portrayal we could get of the page being fully loaded. And so when did that occur in that script I just showed you? So the load event was fired at 133 milliseconds. So as you could see, DOM content loaded was called at 10 milliseconds. So it didn't wait on anything else to finish loading. That just told us that the page was there and it was done loading. But the actual load event was fired at 133 milliseconds. So that was after everything was done, the page is loaded, the scripts have executed, and things are done. Okay, and then I also have, so if you see here, so I'm listening for the load event. I'm listening for it in two ways. Right here, I'm adding the event listener, and then just subtracting the time again, and just getting a measurement. And I'm also using it here in the body tag onload equals, and it calls the same function, does the same subtraction. But here you can see that they're actually about a millisecond off. And why is that? It's variables. It depends on the browser. It depends on many different things. But overall, I'm just showing you that the old way of doing things is very inaccurate. So next is ready state. So what is ready state? We have three strings that we can match on. Loading when the document is finished, interactive while it's parsing, or once it's parsed but still loading, and then complete once it has loaded. So let's go back over here and look at that. So ready state interactive was at 10 milliseconds. Ready state complete was at 133. So it kind of matched the load event. So it's kind of the same thing. They're a little bit ambiguous. So cool, right? So that's the very base level of how we've measured things in the browser in the past. And I also did not go over why I'm blocking the UI thread, but I wanted to simulate document.write 100 times. So it's just a for loop that does document.write down here, just to get an idea, just to make this example take a little longer to load, see what happens. I mean, there's a lot of people that talk about blocking the UI thread and making sure everything's concatenated into one request or not if you're using Speedy or HTTP2. So a lot of controversy around that, and this is just for example purposes. All right, on to the next thing. So enter the navigation timing API. So let's start doing things a little bit better. Let's measure the page better, and let's put a spec around this through the W3C and get a little more organized about it. But it gives us an accurate way to measure page load time. As you can see, the previous example was not very accurate, right? So earlier in the demo, I said I was going to get to this point eventually. HRT, high resolution time, gives you up to the microsecond precision on your timestamp. So when I go out to the browser here, and I actually added that, where did I add that? So I added this oh really performance.now. Same thing I'm talking about, high resolution time. And that's what told us that it really took our script 6 milliseconds to execute when we thought that the script execution starting was at 0 or 1 millisecond earlier. Let's see what we got. Nope. So yeah, it's still sticking around 1. So yeah, that's pretty much it. So HRT, let's actually call this in the browser real quick. So performance.now. It's at 12:8:30, 14 seconds, 17 seconds, 18 seconds. So when I refresh the page here, call it again, it should be at 3, yeah, 2. So as the page is loaded, the lifetime of that load is recorded with performance.now. It is the measurement from when the page actually started executing or when it was actually loaded into the web browser. And from there, it's a countdown, and it continues to count. It gives us an accurate picture of how long we've been running in the JavaScript engine. Okay? So, yeah. Up to the microsecond, let's look at a little example here, another example. So time to get to this line of code, 283 milliseconds. 6 milliseconds. Continues to be 6. Let's look at the source code. This is the source code. So it's very simple, right? So we set performance.now in a variable, and then we call it down here for how long it took to get to that line of code. So very simple example. All right? Good. Let's see what else. So with navigation timing, we get this high resolution time, and we also get a lot of other events. Namely, let me make that a little larger. We get all of these. I'm not going to sit here and name all of them, but if you just Google navigation timing API, you'll go to the W3C specification and see the same chart. And previously thought, I went through all that rigmarole or whatever to show you guys how we did things the old way and kind of all we had to deal with. Now we have a really good API to deal with. And this has been around since 2012, and there's also there's a navigation timing 2 specification now. But we're going to stick with this one. It's basically the same events. So as you can see, we prompt for unload. We've got a navigation start. We have redirects, app cache, DNS, TCP, request response, unload events, DOM content loaded. So we have all these events we can listen to and really get an idea of what our users are dealing with, right? So it's available in most of the browsers out there. All we care about today for this talk is PhantomJS, and I'm going to show you that in just a second. But I also wanted you to see, it would be easy to write a script and support all these browsers and do your own RUM, real user monitoring, and just kind of bake your own and roll it out to your blog or whatever, and just play around with it and get an idea of how to measure these events and how to take advantage of them and see what your users are dealing with. So let's say you have 100 visitors a month to your blog, you could get 100 reports back of exactly how long the redirect, the DNS lookup took, or the request and response. So a lot of really good data you can pull from that. Okay, let's look at another one. So what I've done here, let me show you the source code. This is the source code I'm showing you. A minute ago, we got the HRT, the high resolution time with performance.now. This is performance.timing, which is a different function or API within the DOM. So we're just going to do a quick loop over what this returns. So let's see what window.performance.timing returns. So we get this object back in Chrome. In Firefox, it'll be kind of similar, and it returns all of these things that I just showed you in that graph. So if we go back to and just let this execute, we get all these cool things. Let's see. Yeah. I'm not gonna. Uh-oh. Okay. So anyway, just iterating over the window.performance .timing object, we get all that data from this slide, this gap, right? Everybody cool? Okay. So now, let's see what else we got. That's as basic as you can get to get the data and the timestamps you need. So let's talk about PhantomJS now. It was released, version 2 was released a couple months ago. It's a headless web browser. What is a headless web browser? It is a browser that can run without a windowing environment, so without an X11 window environment, or without being on a Windows machine or a MacBook. We have the ability to run this on a bare bones, Linux installation without having any type of UI. That's what a headless web browser is. You don't see it run. You don't see it pop up and load the web page. It runs in memory and renders the page in memory. Cool? All right. It's based on QTWebkit, by the way. And I'll provide my slides with the links, and you guys can let's jump out to QTWebkit, just so you know. It's easier just to say it's based on WebKit, but there's a Qt project, which is a framework for kind of doing this, and the QTWebkit module is just part of that framework. So what does PhantomJS do? It gives us, what does it do when we run it against Moderniser? This is the list. If you're familiar with Moderniser or some type of feature detection engine, this is their test suite, and it gives us, what's available. And I think over here on it's probably hard to see. Let me enlarge that. I know we've got performance, but anyway. The red stuff is what it doesn't support. The green stuff is what it does support. But luckily for us, it supports the navigation timing APIs. Okay? So we're going to leverage this. We're going to write some scripts. But first, I'm going to give you a brief introduction to PhantomJS. So let's look at some basic PhantomJS examples here. All right. First one we're going to do is screenshot. Actually, I'm going to cat this first. VI screenshot. Oh. So this is the script here. Let me enlarge that for you. Everybody can see that, hopefully. Whoa. No, they can't, because that's not working right. Fall back to an IDE. Let's look at this guy. Nope. So what we're going to do with PhantomJS is we're going to render this Moderniser page that I just showed you, and we're going to spit it out to a PNG image. So PhantomJS can not only render the page in memory and where you can't visually see it, but it can take that image of the site and put it into an image. Does that make sense? Yeah. You can take the site, the markup, whatever, and store it as an image. So let's do like CNN.com. Let's try this. And this is all you need. Script's very simple. I can set the width and the height of the screen. And here I'm going to run it. It's running. Let's see what happened. CNN's taking a little while to load. And here's my new image. It's pretty long. So let me pull that up. So this is what PhantomJS, with that 4 lines of JavaScript you just saw, we can now have an image of our website. And as you can see, some parts of it aren't loading because it's delayed loading, it's asynchronously loading. And this is what we're going to talk about, is how to understand the events in Phantom and how to leverage those to get an accurate view of your page performance and automate that. Okay, so this 6 lines of JavaScript is a basic PhantomJS script that will render a web page to an image. Cool. Okay, what else can we do? We can also look at the repaint of the page. So if you want to see how many times the page is repainted, you can write this many lines of JavaScript and get an idea of how many times layout thrashing is going on or repainting is occurring. So let's run that real quick. What was it? Repaint. And then we'll do the same thing with CNN. Let's see, this is going to be fun. How many times do you think CNN's going to repaint? Who's got a good guess? What was that? 1,000? Okay. All right, let's see. So it takes a little while to load. 225. You get the idea, right? I'm not going to sit here. There's no telling how long we can be sitting here. Let's try Google and just see. If you're not familiar with what repainting is, there's a lot of articles, a lot of good articles out there, layout thrashing and whatnot. So Google did 14 repaints. That's how the browser understands, how the layout's occurring, how the CSS is loaded, JavaScript changing a DOM element, JavaScript inserting a DOM element. There's a lot of causes for repaint, but you want to avoid those as much as you can, especially when you're dealing with like high animation and really paying attention to the frames per second that your animations may be producing. So yeah, so what did I do here? I added 2 new lines of JavaScript to this. One is system. PhantomJS has these modules kind of require based, or you can import these modules. They're built into PhantomJS. They have here we're using web page. You can use system. You can use there's a few others. You can look it up on PhantomJS website. But this system actually allows us to read the arguments. So I'm just getting the first argument from my array, and that allowed me to write a utility in PhantomJS, a script that I could reuse for any URL. So pretty cool, right? I mean, it's simple stuff, and it's easy to use PhantomJS, write your own script, and produce some form of automation or measurement. So what we're going to do is measure the page load. Okay, next. Yeah, let me show you this real quick. This is a lot of really good examples out here. So if you go to phantomjs.org, there's tons. The arguments example I just showed you, rendering, rasterization, page automation. There's scraping, network examples. So a lot of really cool stuff you can do with the tool. So now we get to automate this. So here we go. LoadReport.js is a script. When I was actually consulting at CNN in 2012, we wrote it to measure CNN's homepage performance. And it was a PhantomJS script. And there's a lot of services out there that allow you to look at page load time. There's WebPageTest, really good friends of mine. SiteSpeed.io, which is another really good friend of mine. So all of us in the performance community, we know each other's tools. We know what each other's capable of doing. This particular tool, I just wanted a simple script, a few hundred lines of JavaScript that would give me a baseline of how CNN's homepage was loading. Because when you look at load times, you're looking at money, and you can save. If you can cut down on bandwidth, when you've got 60 million unique users hitting your homepage, you can cut down on bandwidth. You can save a good bit of money, and that's exactly what we did. And we also dropped by being observant of these. You may not. I mean, this graph up here at the top was actually the data from CNN the first year we ran Load Report, and it's pretty spiky, right? I mean, but overall, you can get some kind of normalization of each run. But what happened here? Each dot on that graph is where the Bamboo build continuous integration server kicked off this PhantomJS script. So we had one server or many servers to do the build that checks out the source code. It compiles it, and it executes it. Well, this, we just threw PhantomJS on that same server and the script, and it would just go out and hit the server every time a check-in occurred or every time a build occurred. So it's per check-in, per build, however you want to do it, getting a measurement. And over time, it's pretty cool to look at and see. You know, the top one is resources time. So how long it took all the resources on the page to load. The second one is the elapsed load time. So, and this was using the old stuff that I showed you earlier in this talk. So we were listening to DOM content loaded, the load event, and all that good stuff. So as you can see, the elapsed load time climbed throughout that year, and then we kind of brought it back down. But it's, I mean, this is money. This is money to, and it's not a hard sell to sell this to your boss or upper management. Once you can show them the proof points and help them realize that, hey, bounce rates are relative to our page load time. People will bounce off our site if it loads in less than however many milliseconds. And so LoadReport.js wrote it a few years ago. A lot of companies started using it, and that's what I'm here to talk to you about today, is the new version of LoadReport. This is the first talk I've given on it. It's called SpeedGun.js. So I renamed a really corny name to a really cornier name, or a better name. I don't know. You be the judge. It's basically LoadReport.js rewritten, and it leverages all the PhantomJS2 navigation timing APIs that I just showed you. And there's also some shims for resource timing. Resource timing is another cool specification that allows you to get exact times on how long resources took to load. PhantomJS2 does not have it currently, so we have had to shim that. This is what SpeedGun gives you. Actually, let me just pull it up. So you can go out to GitHub. So let's do SpeedGun. And this is where it lives. It's a simple script, SpeedGun.js, which I have taken here. And let's do PhantomJS. It's exactly like the utility I just showed you, where you run PhantomJS first, you give it the input of SpeedGun, and then you give it -h for help. And that will list out, and there's a much nicer CLI that you can leverage and control how things are output. So let's see. Let's go with http www.google.com/ actually, you know what? I forget how to run my own tool. So let's look. Luckily, there's a README, and there's plenty of good stuff here. So let's do this. Let's go cd/. Yep. Okay. Ooh, that's ugly. Let's see what happens. So what I'm doing right now is I'm loading the same CNN website that I loaded with that simple script we wrote, CNN.com. But this time I'm going to produce a lot better results, and it's still loading. So let's go. Okay, maybe that's not the best site to load over the conference connection. So let's do, oh, you know what? So I'm working on a branch right now that spiders the site. Right now, this utility, you give it one URL or one page, it'll load that one page and produce a nice screenshot, a nice report. But the spider branch will actually detect all the anchor tags in the page, and as long as they relate to that same domain, it'll go through and just spider the whole site and run speed report on every page and do screenshots for every page. Really cool. All right, so git check out. What is it, master? Okay, so now we're back, and we should be able to run this. There we go. So I have a few console outs that kind of tell you where you're at in the loading process. Should be done in just a second. There we go. Okay, so we rendered a screenshot to this reports folder. We have everything's in the SpeedGun directory, cnn.com, and so let's take a look at it. So reports, here it is. Get rid of these guys. So this is our CNN report, SpeedGun report we just ran. So it gave us a screenshot again, and it also gave us a CSV file. And I wish I could enlarge this, but I can't. Let's see if I can do, anyway, CSV file, what's in the CSV file? Actually, you know what, it's a lot easier if I just show you, so you can do the output in JSON, CSV, XML format for JUnit, or you can post that data to a particular endpoint. But I'm just going to show you something a lot easier to read. So SpeedGun.io, which we'll talk about in just a minute, is the wrapper for SpeedGun.js. And yeah. So what I'm going to do here is www.google.com and hit enter. And it's going to put me in the queue. I'm number 1 in line. It's going to start running. And here, the page load time, perceived load time, page process time, load event time, they're all going to start filling in. And I'm going to start seeing screenshots of what SpeedGun.js produced. This server here that I'm running is a wrapper around SpeedGun, the same script I was just running in the command line. This just gives it a better visual appearance. You can read things a little bit better, and it does some cooler things. So what happens is it ran SpeedGun.js 5 times. So for every run, and to give us a median and a true accurate picture of how long what the best load time was for the page, what the worst one was, and what the median was. So here you can see that the page load time, the worst load time for Google was 2 milliseconds, the best was 1.8, and the median was 1.9. So that's pretty much it. And it gives you screenshots as well. But not only does it give you page load time, it gives you, I was going to make a corny joke, never mind, perceived load time. And it also, I'm also trying to tell users about what each one of these things does. So under each header, there's a little blurb about, it's basically me copying and pasting from the W3C spec, or just coming up with my own calculations. Page process time, load event time, connect time, and some of them don't even come up. I mean, if you go out to Chrome and you open up and do the same thing I just showed you earlier, which was window performance timing, all the same data, just letting PhantomJS collect it, but here you see redirect in and redirect start return 0, or unload event, some events return 0, so you're not going to get all the data you need for various reasons. Response times, I can give you response times, domain lookup times, and here we get to our old buddy DOM content loaded, and I clearly say this is measured with the add event listener DOM content loaded. It's the old way of doing things, measured with the old window.add event listener. I'm just throwing those in there just so you could compare and see the differences. DOM interactive. So at that point, you come to this link, and there's a ton more data. When you click on this, you've got secure connection start, fetch start, tons and tons of data to look at regarding performance. And I'm not going to sit here and bore you. You can go check it out, SpeedGun.io. I also give you the fastest resources, single fastest and single slowest resources. There's a bug right now. This is the fastest, and this one is the slowest, and it's coming back with the same one. Sorry about that. I'll get that fixed. Resource single largest, so you get your largest resource for Google. It was whatever this link goes to. The smallest was this base64 encoded image, which was 43 bytes. It also shows you errors that occurred on the page. So think about this. Running this in an automated fashion, we can listen for every check-in. We can detect if that particular check-in is causing errors in the browser. It also gives you nav events, so you can tell. It's a lot funner to run this on CNN. So let's do this. Get a lot better data. Oh, I'm number 3. Some people are running it. All right, cool. let's see, what else? So yeah, so it's the same thing as this running 5 times. So SpeedGun.io is just calling this command line argument 5 times. Yeah, that's pretty much it. So again, SpeedGun.io is available on GitHub. It is allows you to run SpeedGun as a service, and it also is Dockerized. Who in here has played with Docker? Wow, a lot of people. Good, good. You're exactly who I wrote this for. All right. So what we're going to do now is we're going to jump out and look at this Docker container. All right. So yeah, so basic PhantomJS usage, but when you click on server, you have, you can run SpeedGun.io's locally on your machine if you have a Vagrant and VirtualBox installed. But if you have a CoreOS instance or an instance that has Docker natively installed on it, you can basically clone this or pull the Docker containers. You can clone this repository and build the containers yourself. And so you could stand up SpeedGun instances geographically, right? You could stand one up in the US, one in China, one in Europe, one in, yeah, Japan. I don't know. So let's do that real quick, and I'll show you why you might want to do that. Okay, where did that go? Yep. So this directory I'm in right now is SpeedGun. It's the GitHub repository. Same thing you see here on github.com. And what I'm going to do now is I'm going to navigate to the server directory, just as the README told me to, and run server.sh. And this, it's one command to bring up the entire server. There are some prerequisites. While that's coming up, I'll go over those. So to run SpeedGun.io locally, the same server that's available there, you can, all you have to do is install VirtualBox and Vagrant on a Mac, and then run the .server.sh command, and that will pull down the Docker containers for you. It'll do all the setup and necessary stuff. If you run into issues with VirtualBox, there is a fixed VirtualBox script, and that will fix those issues, and you can just start the process over again. And when it's done, you'll have localhost 8081 available. Let's see if it's done. Yes, it is. So now on my localhost, I can run cnn.com. The differences are, we'll hope that runs. So this is me running locally. This is SpeedGun.io here. This, when you run it from here, this is hosted on DigitalOcean. And DigitalOcean, they whitelist, or I'm sorry, they blacklist some sites. So if I go to like www.nike.com, I know I will be blacklisted, and it will be a black screen. Nike blacklists DigitalOcean IPs for security reason. A lot of companies do this. Also AWS IP ranges, they'll blacklist, and you won't be able to run SpeedGun and hit those sites and measure them. So that's why I have this available where you can just launch it through a Docker container, and you know, all is good. So let's see what happens when we run. Okay, so CNN's coming in. And now, so the SpeedGun.io thing, it was on DigitalOcean. The one you see here is running on the Devnexus wireless. So it's pretty slow. It's still running, apparently. I've got CNN loaded one time. But it'll continue to run and run for you locally. There goes another one. So yeah, there comes the screenshot. So it'll load, it'll do the screenshot 3 times. It'll load everything. And again, you know, it looks like there's, let's see, SpeedGun. The GitHub repository is a little, I don't know, there's a lot of stuff in here. But at the end of the day, all that matters is, all that's running here is a SpeedGun.js script. Everything in this repository around it is just there to stand it up as a server. All right? It's try to keep it as simple and as minimal as possible. I don't want, I was talking earlier, another really great service, webpagetestorg, if you've ever been there. It was written, that's why I had to rewrite load report and turn it into SpeedGun. Web page test was written a long time ago, or not a long time ago, but in technology terms, it was quite a long time ago. And to stand up this site, it takes a lot of effort and a lot of setup. That's why I wanted one script that could bring up SpeedGun, and it would be super easy for everyone to stand up on their own. Here you can do the same thing, kind of as I've done, and you'll enter cnn.com, and it'll put you in the queue, and it'll be waiting, and it'll render screenshots for you. So I've simulated kind of all this behavior and just put it into a very simple PhantomJS script. Cool. And yeah, so here's SpeedGun IO. This is us running it on Nike, and all the screens are black. So that's how you know that someone has blacklisted DigitalOcean's IP addresses. It took me a while to figure that out. I thought there was a bug and spent a lot of time on that. So, all right. So here's the one on localhost. So I have two instances running. I got one in the cloud, one here on this machine, and it's loaded CNN 3 times. And as you can see, you can scroll down and see how the page differs as it's loaded each time, and you can get the median, best time, worst time, all that stuff. And you can also get, CNN's got a lot of stuff going on. So here an error did occur, and I admit the UI needs a little bit of love, so just bear with me. So this error occurred, it looks like a Facebook login status or something. Sorry. So as you can see, measuring errors, you can automate that. You can automate load time, you can automate a lot of things. You can automate all the things. Okay, no laughs. All right, sorry. Next and final, how am I doing on time? Am I good? I think so. Yep. Last thing is synthetic RUM, a term you've never heard before. And it's actually mentioned here. New term, synthetic RUM. RUM is real user monitoring. It's something I talked about briefly, but it's where you would take all those scripts that we wrote earlier, like this one, and you would, let's say you're CNN or you're Yahoo or whatever, you would write your own little piece of JavaScript to get the load time and various other things, and you'd send that back home in an AJAX request, right, as a JSON payload or something. You would send that back, and you would collect all this data, and you would be able to say, okay, these 10,000 users, here's the average load time they were seeing from this geographic region. You can do a lot of cool things. That's what RUM is. You instrument your web page so that you can get load times and various other measurements. So what I'd like to do now is simulate that through the Dockerized SpeedGun. So what you could do, and this is the idea, you guys tell me if it's dumb or not, is take, here's a good description of RUM. Real user monitoring, passive monitoring technology that records all user interaction with the website. I think I did a better job explaining it. So what I'm going to do now and show you is SpeedGun IO, centralized point, and I'm going to stand up SpeedGun IO. I'm going to go to my grandma's house and put Vagrant on her machine and VirtualBox, and I'm going to stand up SpeedGun there. So let's say grandma has a DSL connection or a cable modem, and you really want to simulate that, and you also want to go to your uncle's house, your friend's house, put it various places, find an old computer, throw it on there. This is the idea. I don't know if it'll pick up or not, but so I'm going to do that at least here locally and use my cloud instance. So I've got SpeedGun in the cloud, and that's localhost. And what you can do is I actually tell you how to do this on the README. That's not coming up. There it is. So what you can do is start the RUM beacon. So I'm going to go to my localhost, and I'm just going to put this URL in the browser, and it says centralized ping started. And now I'm going to go out to SpeedGun and see what the ping is, see what it's sending me. So there it is. So this is in the cloud, and now my local instance here is every second or every few minutes, whatever, is sending a beacon to my cloud instance. So my IP address here at the Cobb Galleria is 50.58. I'm sure I'm natted through their internal connection. Let's see if I can access this from internally. Maybe not. We'll see if that comes up in a minute. What I want to explain here is, actually, let me take this object. I'll show you what this does. This gives us an object with various things in it. So there are two beacons, right? Are two SpeedGun instances running in the world that are sending this beacon to our centralized cloud server. And what it tells me is the variable data I need to know to at least understand why a report came back crazy. Because if you run SpeedGun.js or any script or any browser on a machine that doesn't have a lot of memory, or its CPU is being used up, or various other things, then your report is going to be swayed just a bit. So this tells me that the machine sending this, or it's really a Docker container sending me this data. This is the free memory. This is the total memory, usable space. I thought I had more than that. I think I cut it back a little bit. I didn't want to send out too much data where people would be like, why is he sending all that data back? But just to troubleshoot things. So if this, let's see if this came up here. Nope. So it's not, this network is probably blocking 8081, or it's not letting an internal connection back to this IP that's assigned here. If this was my home Comcast connection, I could access it. And so at that point, I would have a Comcast cable modem in Mountain View, California, and I would be centralized server on DigitalOcean, and I would be able to launch multiple SpeedGun reports. So that's only one node, but you could ultimately do that with all the IP addresses you've collected. So you could set this up at 20 different IPs, or 20 DigitalOcean instances, or AWS instances geographically located. I know DigitalOcean does SF, I think New York, and then one in, I know they have 3 geographic locations, but you get what I'm saying, right? You can stand up your own network, your own SpeedGun or PhantomJS network, whatever you want to call it, and have reports ran geographically for page load time. And that, my good friends, is the end of my talk. Thank you very much. And I'm open for questions if anybody has one.
So the data you were showing for CNN, it looked like you were running it on some interval dashboard, and it looks like on CI.
Yeah.
How are you doing the post of the data? What were you posting it to trend that at the time?
Yeah, I can show you. It is actually in the, so the question is, how did I post the data to get those screenshots? I have this somewhere here. This is post image. So I have an endpoint available on my server there in the cloud, or on any SpeedGun. Anytime you stand up a SpeedGun, you have this endpoint available that will accept the image data. And so when I go down here, I post that image to that endpoint, and I take do the post, application JSON, base 64. The base 64 data is sent to my endpoint as text or as JSON, and then I take that and I'm rendering out the base 64 encoding as an image. So I'm not actually doing a physical file upload. It's just posting a lot of text, a lot of base 64 text.
Right, but it looked like you were trimming that over a long period of time. So does the SpeedGun, are you storing that somewhere and then rendering that, or?
The base 64 data? Yeah. So the base 64 images are not persisted just for that one, because there's a queue, and each report is ran one at a time to leverage the system resources. Because if I let 20 people run the report at the same time, it's going to go down. So one at a time, report running, and those base 64 strings are stored in a table with 5 rows, and they get overwritten each report. So. Did I misunderstand? Yeah. Okay. Let's go back to the C then. Okay.
In the PowerPoint, right, where you had it, what looked to be trended off the CI runs for a long term.
Oh, yes. Sorry. Yeah, I completely misunderstood that one. Sorry about that. Where did that go? Yep.
Yes. So what is that report coming from? Where are you posting the data to generate these types of reports?
That data, the guy who integrated that with the CI build, and the question is, where does this data come from? Where does it go? He wrote a quick script that would put that in a MySQL database.
Okay, so this was all internal to CI.
Yeah.
It's just some homegrown thing.
Yeah.
You're not using any other COTS products like Sonar or anything like that? Okay.
No, this was all one PhantomJS script, and then he would pick that up on a time, maybe it was a cron job or something, that he would pick it up and just import that data into the database, because all PhantomJS will allow you to output is CSV or JSON or something like that. It's not gonna, it doesn't hook directly to a database. So that you've got to fix that middle part. Any other questions?
So how could build my team, like developers want to be able to, I'm working on a page on developer, I want to be able to do that and find out what happens when I get some sort of consequence, say 25, it's 50. How could I do that with this? This seems very lightweight, I like what I'm seeing. How can I now take this to the next step?
If you wanted to measure, so your question is, you want to measure when 50 concurrent connections are made to the site? That would be outside the scope of this. You would need to, that would be more server logs, like timing on the server side, I guess.
I mean, we should be able to go to traffic and just use this to run.
Oh, well, yeah, if you ran SpeedGun across 50 instances, is that what you're talking, like running it 50 times? Yeah, no, it's a good idea. Or what are you trying to get at? Are you trying to get at how it might impact the load of the site or the resources of the site? Like what's your end goal? Okay. Yeah, this. That's a great question. But yeah, this is not quite the tool for that yet. Maybe it will be one day. So yeah, good question. All right, anything else? Anybody else? Any other questions? All right, thanks guys, appreciate it. Good thing.
Can I get your slides?